this lesson, we're going to look at different sampling techniques. How would you select a representative sample? Every possible sample of the size we plan to draw must have an equal chance to be selected. So therefore, each combination of people has an equal chance of being selected. A sample drawn this way is called a simple random sample. Or we can abbreviate it as SRS. This sampling method is the standard against which we measure other sampling methods, and the sampling method on which the theory of working with sample data is based. If we want to select a sample at random, we first need to define where the sample will come from. So we have what's called the sampling frame. And it's basically just a list of individuals from which the sample is drawn. In practice, the simple random sample are often selected automatically by a computer. You provide the sampling frame and the sample size you want, and it produces a simple random sample. So for instance, like if I wanted to sample my class, so this class particularly, the list of students would be my sampling frame, and then maybe I just want to take a random sample of 10 of the 28 students that are in this class. Samples drawn at random generally differ from one another. Every sample is going to be different, and that's due to something called sampling variability or natural sampling variation. It's unavoidable. Okay, that's just how samples are. It's natural. Don't look at sampling variability as a problem, but rather an opportunity. Surprisingly, sampling variability is quantifiable, so we can assign a number to it, and we can know how large it might be. Later in this course, we'll investigate what the variation in a sample can tell us about its population. Okay, that's always what we're interested in. There are 80 students enrolled in an introductory statistics class, and you are to select a sample of 5. How can you select a simple random sample of 5 students using these random digits found on the internet? So sometimes this is referred to as a random number table. You can look them up on Google, and you can pull up these tables that are filled with numbers, and you can use them to select random samples. So if I have 80 students and I want to just pick 5 of those students randomly, right, how could I go about doing that? So one of the first things I would need to do is I would need to number the students, since I'm going to be using these numbers here to pick who my sample will be. So I can number the students, and maybe I want to number them from like 0, 0 to, I need 80 numbers, so 7, 9, that's 80 numbers. You could do 0, 1 to 80 if you wanted to. Okay, I want to make sure I ignore any duplicate numbers that might come up. Okay, that's important. And of course, disregard any, numbers that will come up that are greater than 79. Okay, so I'm going to ignore any duplicate numbers and any numbers greater than 79. Okay, you can also say 79 to 99, right? Since we're going to just look at 2 digits at a time. So we're going to take random numbers using the table, 2 digits at a time. So if I do that, my first 2 digits are 0, 5. Actually, I'll put that here. The next 2 would be 1, 6, and then 6, 2, 9, 3. Okay, so I have 4 numbers now. I need 5 numbers, right? So my next one's 0, 5. If you notice, 0, 5 was already used, right? So we can't use that. 93 is bigger than 79. Can't use that one. So I have to keep going. Okay, 77's okay to use. And I need one more, 48. So there's my 5 numbers, okay? So my simple random sample consists of the following 5 students. Whatever students are numbered 5, 16, 62, 77, and 48. All statistical sampling designs have in common the idea that chance, rather than human choice, is used to select the sample. So in that last example, we used a random number table to select the 5 students. Each student had an equal chance of being chosen. Out of the 80 students, I picked 5. They all had the same chance. Sometimes what we can do is slice the population into what's called homogeneous groups. And that just means same, right? So there's something about the individuals in that group that's the same. And we call those homogeneous groups strata. And that's before the sample is selected, okay? Then what we do is we perform a simple random sample, so an SRS, used within each stratum before the results are combined. This common sampling design is called stratified random sampling. So let me give you an example. So let's say there's a road here with little side streets. Okay, and here's the road, and we'll just take the road out front of our campus here. So this is Livingston. Okay, and then you've got all these side streets here. Let's say the city wants to do road work and on Livingston Street. And they want to find out from the neighborhood if they're okay with this. Is this going to be an inconvenience? Do you think we can use taxpayer money to do this? Are you okay with that? So they decide to do a survey. They don't want to survey the whole city of Orlando because it doesn't affect everyone. Also, it would be very costly to survey every single person on each of these streets. So if we were to do a stratified random sample, what would happen is we could use all these side streets as the strata. So you would basically here take each of the streets, so all the side streets, and then choose random houses on each street to send a survey to. Okay, you could use address numbers, you could number the houses and use the same thing that we used above in the last example, the random number table. But that would be an example of stratified random sample. The strata would be these side streets. They're your homogeneous groups because everybody on this street, is living on the same street. Everybody here is living on the same street. So they're the strata. And then you would randomly choose houses in each street to send your survey to. And then you would collect your survey and find your results. Okay, so that keeps in mind the randomness, which will delete any bias that could occur. Okay, you'll probably need to pause the video to read this problem, and then you can unpause it when you're ready to go over it. A certain county has 4 high schools, north, south, east, and west, and each high school has 4 class years. A member of the county school board would like to estimate the proportion of all high school students in the entire county who hold part-time jobs during the school year. Because a census would be too difficult, they plan to base their estimate on a random sample of 200 high school students from the county, and they believe that a stratified sampling strategy may improve their results compared to using a simple random sample. They are trying to decide whether stratifying by either high school or by class year would be better than using a simple random sample. How should the school board member decide whether stratifying on either of these variables would be better than using a simple random sample? And what does better mean in this context? So first of all, you got these 4 high schools, right? North, south, east, and west. And out of those high schools, you've got 4 grade levels, freshman, sophomore, junior, senior. Okay, so that's out of each of them. Okay, so they want to know, should they stratify by high school or by class year? And would that be better, okay, than doing a simple random sample? And what does better mean, right? So here, stratify works better than, the more strongly the strata are associated with the variable of interest. So my variable of interest here is, I want to know, like, do the students, how many students have a part-time job, okay? So if the proportion of students holding a part-time job varies a lot across the 4 schools, stratified is better than simple random sample, because if I did a simple random sample, each student in all those schools has an equal chance of being chosen. But if not every school has the close to the same proportion of students working part-time jobs, I'm really not going to get a very representative summary of my data that I could apply to the population of all 4 schools. If the proportion varies a lot across the 4 class years instead, stratified is still better, okay? And better just means that, so better in this case means the stratifying sampling strategy is more likely to produce a sample that's representative. There's that word representative again, that's the key, of the population than a simple random sample. Okay, so again, if there's a lot of variation in the proportion of students who work part-time jobs in each high school, stratifying's good, because then you're getting a fair representation from each school. And the same goes if the percentage of part-time students in grade levels also varies. When we think about different subgroups of the population, they tend to have different responses, right? So every sample is different by natural sampling variation. So going to the extra trouble of choosing a stratified sample offers us the important advantage of reducing that sampling variability. Splitting the population into representative clusters can make sampling even more practical. Okay, so this is different than stratified. Then we could simply select one or a few clusters at random and perform a census within each of them. This sampling design is called cluster sampling. Clusters are generally selected for reasons of efficiency, practicality, or cost. So let me give you an example of cluster sampling because it's very similar to stratified. If we go back to that little example I gave you where, let's say the city of Orlando wants to do road work on Livingston Street. Again, they don't have the time or the money to send surveys to every single person living on these side streets, right? And we know that in all reality, not everyone's going to answer the survey. So they just need a sample. Remember, the number matters more than the percentage or proportion of people in the sample. So for census sampling, for cluster sampling, these side streets would be your clusters, right? Those would be your groups. So what you would do for cluster sampling is you would randomly pick, let's say, 5 of the side streets. And then you would send a survey, which is, in this case, a census is a special type of survey that you would send to all of the residents there. So, you would maybe number the streets and then use a random number generator or even a random number table to select the 5 streets that you want to survey. And then you would survey every person living on that street, which is the cluster. So it's easy to remember, like cluster starts with a C and then census starts with a C. So you're surveying every single person. Okay, so again, here's that same problem. You may want to pause it so that you can read and then respond to it. A school board member in a county with 4 high schools wants to estimate the proportion of high school students in the county who have part-time jobs using a random sample of 200 students. They considered using a simple random sample and two possible stratified sampling strategies, but all of these methods have involved tracking down a lot of students all over the place. Fortunately, the principals at the 4 high schools will all permit the school board member to survey every student in each of a few homeroom classes, but only a few. Each homeroom has about 20 students at all the schools. How would the local school board member use this fact to draw a cluster sample? How is this an improvement over the other sampling methods that were considered? And do you have any concerns about this cluster sampling method? So randomly, the way they would do the cluster sample is they could randomly, is the key word here, sample maybe 10 homeroom classes. So those homerooms would be your clusters from among all the homerooms across the county. Okay, and then they would use that sample of 200 students so maybe 20 students in, if there's 20 students in each room, you would get 10 times 20, so the 200 students. Or if there was more than that, they could then, out of that pile, they could randomly pick 200 students. So in this case, the cluster sample is easier to carry out than a simple random sample or a stratified, right? So let's think about why that is. Well, if it was a simple random sample, they would have to travel potentially to all 4 of those high schools. And we don't know how far apart those schools are. So that would take a lot of time. And that also goes for stratified because you're either stratifying according to the high school or according to the grade level. So again, that would be a lot of running around, right? So here, you're only having to go to 10 homeroom classes. And that's a lot less, right? So it would cut down on time, okay? Would we have any concerns? Well, it may produce a fairly representative sample if the proportion holding jobs is consistent across the county. Otherwise, it could be unrepresentative, of the students that hold part-time jobs in the county. So cluster is easier to carry out since you visit only 10 classrooms, and it could produce an unrepresentative sample, which is what we don't want, because then the information we get from that sample is kind of useless. We can't really apply it to the population. So it could produce an unrepresentative sample, right, which is not very helpful. So that could be a potential problem or concern that I would have. So what is the difference between stratified and cluster sampling? Again, they're very similar, right? So one way to remember it is we stratify to ensure that our sample represents different groups in the population, the strata, and then we sample randomly within each stratum. Strata are internally homogeneous, but they differ from one another. So again, the street work problem, the streets are homogeneous in that anybody living on the same street is in the same strata, but every street is different. Okay, by contrast, we select clusters to make sampling more practical or affordable. Clusters can be heterogeneous, so they can be different. We want to randomly selected clusters to provide a representative sample of the population. So we need to be really careful. Easy doesn't always mean that it's going to work out like that. Sampling schemes that combine several methods are called multi-stage. So you can do more than one method. sampling method every time you take a sample. Most surveys conducted by professional polling organizations use some combination of stratified and cluster sampling. So, that would be multi-stage. They also use, in addition to stratified and cluster, they may use simple random samples. Some samples select individuals systematically. And that would be like you survey every 10th person on an alphabetical list of students, or you survey every 5th house on the street. Okay, keep in mind though, if you just do that, it's not really random. So you could introduce bias. So you still need to make it random somehow. So you must start the systematic selection at a randomly selected individual, and the order of the list must not be associated in any way with the responses sought. Okay, so then we have what's called a systematic sampling design, and it will give a representative sample. So something you could do, if you go simply to like Google, type in Google random number generator, and this comes up. Maybe you type in you want the number generator to generate a random number for you from the numbers 1 to 10. Okay, so all you have to do here is hit generate, and it gave me the number 8. Okay, that's a random number. All 10 numbers had the equal chance of being chosen. But now you had the computer pick it out for you rather than you yourself. Because maybe there's someone on a specific street that you don't feel like surveying. You could, avoid going to that person's house by not surveying them. You could pick a different number. Maybe they live at the 4th house and you're like, I'm not going to survey them because I know how they're going to respond to the survey. So then I'm going to go to the 5th house. So I'm going to choose every 5. But when you do that, you're biasing your results, right? And that's not something we want to do, because the whole point of taking a survey, a sample, is to be able to then, determine information from that sample that applies to the population. Okay, so let's review really quickly the different sampling techniques we talked about. Let's pretend we need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. You want to name each sampling method described below. And you may have to go back and look at the different sampling techniques. First one is pick every 10th passenger as people board the plane, starting with a randomly chosen passenger among the first 10. So every 10th, there's a system to that, right? So that would be systematic sampling. From the boarding list, randomly choose 5 people flying first class and 25 of the other passengers. So there you have stratified, because your 2 strata would be the first class and the other passengers, and then you're randomly picking people within each of the 2 groups. So that's stratified. Randomly generate 30 seat numbers and survey the passengers who sit there. Okay, so that would be your simple random sample. Randomly select a seat position and survey all the passengers sitting in those seats. So that would be cluster sampling, and the only cluster here that's being sampled is just whether you're sitting on all the people at the right window, or all the people in the right center or right aisle, etc. So since you're only surveying one cluster, you need to really put a lot of faith in the assumption that the cluster that you select will be a representative cross-section of all the passengers. So just be really careful and mindful when you're dealing with cluster sampling. At this point, you can pause the video and read the question and then answer the question, and then we'll end the video after that. The assignment says, conduct your own sample survey to find out how many hours per week students at your school spend watching TV during the school year. Let's see how we might do this step by step. How would you design the survey? And remember, actually collecting the data from your sample can be difficult and time-consuming. So the very first thing I need to look at here is, what exactly am I going to be trying to measure? What am I going to try to find out? And I want to find out the number of hours per week students at school watch TV, okay? So that's my parameter of interest. Okay, so if I want to conduct a sample survey, I need a list of students. That would be my sampling frame, right? So I want to first obtain a list of all students. And of course, it would just be the students enrolled, right? And that's your sampling frame, because from that list, we're going to randomly select some. Okay, so then we want to ask students very specifically, how many hours did you spend watching TV last week? You want to be really careful when you ask the question that you're not incorporating any type of bias into your question. You also want to make it easy for people to understand. Easier is better, and because you'll get a more accurate response from the person that's completing the survey. Okay, and also keep your survey short. So maybe the next thing we would want to do, since we are conducting a survey, and it's people at the school you go to, you could maybe do a simple random sample. Okay, of course you could always, design a cluster sample or a stratified. So in both cases, your clusters or strata could be the different grade levels, right? Sophomore, senior, junior, and freshman. And then, randomly pick within. What I would want to do is maybe get an alphabetical list of students. And we would want to number them, of course. So maybe assign them a number from 0 to 9. And select all students who, let's just say, were assigned a number 4. Okay, so you've got all these students at your school. You put them in alphabetical order. You number them from 0 to 9, and then just select everyone that's a 4. And you can get this number from your random number generator, right? So somehow from random number generator. Again, you don't want to be the one to pick it because that would be biased. Okay, and then maybe you can send surveys by email. And you want to keep in mind, be thoughtful of students that maybe don't have access to email. So you could always hand deliver to those without email. And of course, you can always just hand deliver to everyone, except, again, you got to think about like paper consumption and the effectiveness of actually like walking around and handing people a survey, making sure that you get it to every 4th person. It would be very time consuming. So these are things you need to think about. When designing a survey, you want it to be, as I said, easy, right? And we also want it to be valid. A valid survey yields the information you're seeking about the population. Again, that's the key. Before setting out to survey, ask yourself the following questions. So what is it that you want to know? Am I asking the right respondents? So make sure you use the right sampling frame. Am I asking the right questions? Tune your instrument. Longer surveys yield fewer responses. People just get tired of answering the surveys. Okay, so thus a greater chance of what we have called non-response bias, where people choose not to respond, and then you don't get their information. Ask specific rather than general questions. Like we specifically asked, how many hours a week did you spend watching TV last week? Ask for quantitative results. So a number, how many hours, a number. Okay, be careful in phrasing questions and answers. Again, you want to avoid biasing anything. And then what are you going to do with the answers? How are you going to measure the results? And how are you going to apply that to the population? The best way to protect a survey from unanticipated measurement errors is to perform what's called a pilot survey. And a pilot survey is a trial run of the survey you eventually plan to give to a larger group. And basically what you would use is just a draft of your survey questions, and you would just administer it to a small sample drawn from the sampling frame you intend to use. So the same list of individuals, maybe just different individuals, and you could randomly select them, just a small amount to test your survey. Bad sample designs yield worthless data, and many of the most convenient forms of sampling can be seriously biased. And there's no way to correct for the bias from a bad sample. It's wise to pay attention to sample design and to be aware of the reports based on poor samples. One of the most common dangerous sampling methods is what's called a voluntary response sample. Oh, that did not turn out to look like voluntary at all. Okay, and voluntary response samples where a large group of individuals is invited to respond, and those who choose to respond are counted. If you've ever gone to like Universal or Disney and they have people there standing trying to get you to answer some survey questions, that's a prime example of voluntary response samples. They really don't give accurate response at all because people they volunteer to respond or they don't, right? So examples include call-in shows, internet polls, letters written to members of Congress. That all has voluntary response. Okay, rate my professor. That's a voluntary response sample. Voluntary response sampling is almost always biased. So conclusions drawn from such data are almost always wrong. The sample is not representative, even though every individual in the population may have been offered the chance to respond. Okay, the resulting voluntary response bias, makes sense that it's called that, right? Invalidates the survey. Something very similar to voluntary response sampling is another type of sampling method that doesn't work, and it's called convenience sampling. And in this type of sampling, we simply include individuals who are convenient for us to sample. Fortunately, this group may not be representative of the population. So, if you were to survey your friends on Instagram, well, that's convenient sampling because they are a sample that's convenient to you. They're not necessarily representative of the population, which is what we want information about from our sample. Okay, you may want to pause the video and read the two problems. And for the first one, you're going to talk about which sampling strategy and what's wrong with it. And the same thing with number 2. A local school board member would like to estimate the proportion of high school students in the county who hold part-time jobs during the school year. Knowing the football games between 2 of the county's high schools draws lots of students from all over the county, they consider simply attending a football game and surveying all the high school attendees that they can. What's wrong with the sampling strategy? So first of all, what type of sampling strategy is this? And they're going to be using what's called convenience sampling because they are at the football game, right? It's convenient to just survey the people there. And it's likely to be biased. Okay, why is that? It's biased for a couple reasons. Maybe people with part-time jobs are more likely to attend because they have the money for admission. So maybe there will be a lot more people there with part-time jobs, but then you don't get the people that don't have part-time jobs. Or vice versa, they're less likely to attend because they're actually at their jobs, right? So a couple reasons there. So part-time students with part-time jobs may be able to afford the admission. So mostly all part-time job people will be there, and then you don't get the people that don't work part-time. Or vice versa, they are working, so they're not there, and then you don't get their response. So that's not going to give us accurate information about our population. And number two, a local school board member would like to estimate the proportion of high school students in the county who hold part-time jobs. They are considering posting questionnaires at the exits of the 4 high schools and inviting students to complete one and drop it in a provided box. What is wrong with this idea? Well, there's a lot wrong with it. So first of all, they're unobserved questionnaires, right? There's no way to know the responses are coming from the high school students. They could give it to someone else to complete, right? Also, how do you know that the students are not submitting more than one response? So that can be a problem with voluntary response bias, right? So you don't ever want to use unobserved questionnaires. That's a bad way to question and find out information about your sample/population. Okay, we're going to end the video there. Please join me for the last part of the video where we're going to be talking about more types of bias, things to think about with that, and then we'll do a review question at the end. Have a great day, everyone.